Hello students. Moving on with the second concept in the projection of planes. We have a categories where we come across locus line and non-locus line problems. In this one, we have a few categories where we look forward for a median in a triangle and a diagonal in a square or a bisector in a pentagon or a diagonal in a hexagon or maybe the diameter in a circle. Okay, so whenever we get a words which are inclined to VP or HP in the third position, then these type of problems we call it as a locus line problem. Okay, so how to go with that one we'll see one by one, but before that one, so all these locus line problems are resting on a corner. Say for example, when we tell a diagonal or a median or a bisector, so all these are originated from a corner of a plane. Okay, so for that one, say if you take a problem number 9 here, so what it says here is there is a square plate which is a 40 side rests on HP such that one of the diagonal is inclined at 30 degree to HP and 45 degree to the VP. It means there is no clue for or there is no particular direct answer where we come across it is resting on a corner. But when you look for this diagonal, so the diagonal is originating from a corner. So that means it is resting on HP on one of its corner. Okay, so then the lamina makes 30 degree to the HP and the diagonal is inclined at 45 degree to the VP. That means it's a locus line problem. That is we need to find a beta. Okay, so how we'll see one by one. Again, to start with that one, we'll take a line with a point 1 3. Okay, so we'll have one horizontal line, and when it comes to the text, so we'll have x and y. So in order to construct a square, we have a option called a rectangle. Once you click a rectangle, we'll come across a width and a height. So the width and height in a square will remain same as 40 and 40. And when it comes to the angle, when it is resting on a corner, it is a 45 degree. Press enter 45 degree and keep the square here. Okay, and the square should be of a zero point 0.5. Okay, so now the condition for resting on a corner is, so whenever we have a diagonal, okay, the diagonal should be parallel to the xy line. Now you can check it out, this diagonal is parallel to the xy line, and the corner should be left side to the observer. That means we start naming from the left side, that is A and the B and the C and the D. Okay, see, one of the diagonals should be parallel to the xy line. That's a condition for resting on a corner. So if you go to the smart dimension and if you click here, so in order to insert a square symbol, you can just click, that is select the dimension, go to the prefix, and here you will get a square symbol. Check and click OK. So you will get a square symbol here. Okay, that is a very important thing for these categories. And rest and all again will follow the same method. We'll take up a point 1 3 line. We'll have a projection from A to the xy line, from D till B, then to the xy line, then from C again back to the xy line. So once it is done, take a point 0.5 line. Should be a discontinuous line from each of the vertical line. Then when it comes to the naming again, here we'll be having A dash. Here we'll be having a D dash in the bracket B dash, and then here we'll have a C dash. Okay. So once this much is done, just zoom this much of area and move those naming a little bit above the xy line. So things will be easy for us to move it. Okay. The next one, the diagonal is inclined. That means this is the diagonal. This line itself is representing the diagonal of a square. So select that diagonal and copy on from the left hand, move to the next position. Then it is inclined at an angle of 30 degree to the HP. So visible in the front view. So left hand and the right hand. So it's a 30 degree. Press enter and the left click. Okay. So very first thing is go to the angle between, measure the angle between this line and this line is a 30 degree. So once this one is done, go to the move command, copy on, move the naming. This is A dash, this is a D dash in the bracket D dash, and this is a C dash. Okay. So here we can use many methods. Again, I will use a alignment indicator. So where I will come across with the A, then I will enter minus 90 degree. Then A will come here. So just connect to the C now. Then from here, the first it is a B. Okay, then connect to the B. Then it comes to the D. Come down. So enter 90 degree. Come to the D and connect it to the D. Then last is a C. We will come on our same line with the A. Okay. So when that one is done, change the line thickness to 0.5 and connect each line with the zero point 0.5 thickness. Okay, so then go to the move command, copy on, select the name, move it. This is A, and this is B, and this is C, and this is a D. So one this one is done. So first and foremost thing is, so we need to measure the diagonals here. Go with the distance between the diagonal which is passing through the resting corner is A and C. Okay, the first length will be 56.57, and in the second position A to the C is 47.22. Okay, so we need to measure two lengths, and here in order to construct uh, the locus line problem, so we have a few steps here. Okay, we refer this one as a first length, and the inclination they have given here it's a 45 degree, so that we will refer as a first angle. Then second length, and we need to find the second angle. Okay, so there is a little variation in the length not connected to the edge here. So take up a point. So be careful while connecting the lines. You can just zoom and see the things. Now let's measure the distance between A to C. It's 48.9. Okay, so be careful here. So now once this one is done, so first step is when we go for a locus line is a first length. First length is 56.77. Enter. The first angle is 45 degree. Enter. You will get one inclined line. Keep it below the XY line. Okay, then drop one horizontal line from the bottom end towards the right side. That's a step 2. And the third step is arc by center point. Okay, from the top end, the second line that is 48.99 as a radius, cut it on the horizontal line. Okay, and the fourth step is go to the trim of the extra arc and the extra line. Now connect this end of the arc till the end of the top line. Okay, so first thing is you go and measure the angle between the first line which you have taken, it's a 45 degree. Okay, the next line is how much we are going to get, it's a 55 degree. Then whatever the problem you have done is a proper. Now for a timing you just undo for the uh, dimension. Now zoom both the views here. Okay, we need to place this square, okay, on this second line, the one which we got it as a 55 degree. Okay, first go to the move command, copy on, take it from A, keep the A at the top end and right click. Then go to the rotation command, take the A, the one which you kept, and the opposite corner, that is C, move it till the end of the arc. Okay, that's very very important. Okay, so we'll repeat it once again. So select the square keep, which you kept at the top, go to the rotate command, same end A and corner C, and move it at the end of the arc. Okay, once that one is done, go to the move command, copy on, move the A till the A, then C at the C. Okay, so then the B will be to the down and D will be to the top. Okay, now measure the angle. You know the angle will remain same, because in order to avoid just confusion between the lines and the angular line. So we just kept that aside. Okay. So now again go back to the line with the point 1 3. Okay, take it from A, use alignment indicator, it comes to the XY line. You can see A is on the XY line. So keep it here. Then go to the B. So B is at the mid run. Move down. Okay, click here. So then go to the C. Where is C? C is here. And then is move down. So C is here. Connected to the C. And last one is a D. D is on the point B. Okay, now change the thickness to the 0.5. Connect to the C, to the B, to the A, to the C. Okay, so now the last thing is zoom this one properly. Okay, so move all the naming here. The A is A, and B is B, and C is C, and D is D. But without fail, those things are front view, so better add a dash there. Go to the move command, take a dash, and move to the each alphabet A dash, B dash, C dash, and D dash. And one more important thing is move this C dash to the end of this one. This is how exactly we can do the locus line problem. Locus line problem is this line is going to act as a locus of the true and the apparent line. The same whatever we have discussed in the line problem. Okay, if you see here, okay, whatever like median or bisector or diagonal or maybe the diameter, if they ask like these things are inclined to VP in the third position or inclined to HP in the third position, so this is how exactly we do. We take a first length and give an angle and we drop, and then horizontal line, then arc by center point, the second length as a radius, and third one trim off, then fourth one measure the angle, then move the whatever the lamina from that position to here, and finish up with the visibilities. Okay, so that's how exactly we can do. So thank you.